Hello, future doctors of education. First, I would like to congratulate you on deciding to continue your educational journey. There may be some bumps and bruises along the way. Sometimes you may cry and feel like giving up, but don't. The end result is worth every step it took to get there. The objective of this course, Introductory Research Methods, is to provide you an opportunity to establish an understanding of research proposal writing, research methodology, and foundational research theories and protocols. You will gain knowledge in the areas of designing a research project, analyzing research results, and production of different research studies. This course will provide you an overview of research intent and design, methodology, and data collection. It is my pleasure to introduce to you the first section of your course.
During this presentation, experimental randomized designs will be discussed. This is just one type of quantitative research design. During this presentation, you will be introduced to the definition of an experimental design. We will look at what is meant by randomization and look at the difference between random selection and random assignment. We'll also attempt to offer the explanation of how random selection and random assignment might help to reduce experimental error and mitigate the threats to validity. We will look at what is meant by validity, and we will critique 3 sampling methods for experimental randomized designs. Experimental designs of research can be used to establish possible cause and effect between your independent and your dependent variables. It's a method of research that's mostly used in the social sciences such as sociology and psychology, in which a controlled experimental factor is subjected to special treatment for purposes of comparison with a factor kept constant. This is your experimental group and your control group. It's one of the most common research methods used. Now, according to Creswell, 2012, experimental research began in the late 19th and early in the 20th centuries. But at first, it was a common practice to use an experimental group and a control group. It wasn't until 1913 that the idea of randomly assigning participants to groups was introduced. Now we're going to take a look at the definition of randomization. Randomization refers to the practice of using chance methods. For example, flipping a coin to decide, which subjects will be put in the treatment group and which ones will be put in the control group. In the process of making something random, in various contexts is involved. For example, allocating experimental units via random assignment to a treatment or a control condition. As you see in the diagram, you have a group, your population, and just by flipping a coin or using a random table, the samples, participants are selected to actually be in the sample to represent that population. After coming up with the idea of what it is that you want to do your experiment on, what is it that you want to test? It could be an idea, or it could be a practice or a procedure. Your next step is to select your members for your sample. Now you want your sample to reflect the population in which you are testing. Now, of course, it's impossible to test everyone in the population. Therefore, you want to draw out a sample. Selection is the process used to draw an sample of participants for your study from that population. Using randomization selection, every member of the population has an equal chance of being selected to be a member of the sample that you're going to use for your study. In randomization assignment, every individual in the study has an equal chance of being assigned to any group that receives treatment or any group that receives no treatment. For example, if you have a group of individuals and one group you want to give breakfast to, but the other group that you don't want to give breakfast to, your breakfast group will be your treatment group. Your no breakfast will be your control group. In randomly assigning individuals to the groups, each member of the sample that you selected from your population has an equal chance of being either in one group or the other group. This is a process used to assign the sample that was drawn from the population to different groups or treatments in your study. As you can see, they are similar. Random assignment, and random selection. Random selection is the actual drawing of the sample from your population. Once you get your population, you can randomly assign your individuals to either one or another group. But in both cases, each one have an equal chance of being in either in any of the groups. There's no restraints that makes it impossible to assign them to either group. Here we have a perfect example of random sample versus random assignment. On the left-hand side, you have a population, and from that population, a sample is drawn. And the sample is drawn randomly. The arrows actually depict, how the samples were drawn in no particular order, by no particular characteristics. Each member of the population has an equal chance of actually being selected for the sample. On the right-hand side, you have an illustration of random assignment. After the sample has been selected, the researcher can then equalize the two groups, the control group and the experiment group, using the members from the sample from the population. So when you put it all together, you begin with your population. Random selection is associated with selecting participants for the study from the population. Once they are random selected, you have your sample. From your sample, the participants are randomly assigned either to the experiment group or the control group. Once you have those two groups, you can put treatment to one or the other. The control group usually do not receive a treatment, and in order to see how it's going to, you're going to put the treatment to see how they're going to affect your independent variable. Here are two ways random selection and random assignment might help to reduce experimental error and mitigate threats to validity. First of all, in any population of people, no matter how randomly you select them, you're going to have differences. People are going to have different characteristics. By randomly selecting your sample and randomly assigning them, it's a possibility that you can spread those characteristics equally among the groups, the experimental group and the control group. Also, The, the researcher will be able to provide better control over the extraneous variables. Sampling methods can be divided into two different types of sampling: your probability sampling and your non probability sampling. Your probability sampling refers more to your random types of sampling methods, whereas your non probability sampling refers to a non randomized method of selecting individuals. Simple random sampling is, as we talked about earlier, each member has an equal chance of being included in either the experimental group or the control group or any group in the study. The stratified random is a little bit more technical than the simple random uh, sampling, whereas the targeted uh, population is divided into groups. Then the samples are randomly selected from each group. Now, if we talk a little bit, just for comparison's sake, non-probability sampling will be just snowball sampling, whereas it works mostly on a referral basis. The first respondent refers a friend, and that friend's refer a friend, and so on and so forth. Or your quota sampling, where you have categories of divided. People are selected according to the category interest. Um, some may be interested in being in the category for age or gender or whether or not they're Christians, and so on and so forth. In order to have a random selection method, you must first set up some kind of process or procedure that ensures that different units in your population have equal probabilities of being chosen. The old way of doing it would be to pick the names out of a hat, or maybe someone chooses shortest straw. Today, we have more sophisticated ways of doing it. There are computer programs that can be used that can actually do this process for you. The sampling method that you choose is going to depend on the population of interest. And remember, sometimes you can combine different methods, but careful planning is the key, so that you will generate reliable results. And always have a continuous plan.